There's an old saying that tells us that in order to understand recursion, one must first understand recursion. But in order to understand recursion, one must first understand recursion. So one must first understand recursion in order to understand recursion. Recursion is the process of repeating items in a self-similar way. So for instance, when the surfaces of two mirrors are exactly parallel with each other, the nested images that occur are a form of infinite recursion. In mathematics and computer science, a class of objects or methods exhibit recursive behavior if they can be defined by two properties. The first, a simple base case, and two, a set of rules that reduce all others to the base. So let's look at an easy example. Here's mom and dad and baby. We have mom, dad, and baby, but we can also realize that mom was once baby to another set of mom and dad, and dad was also once baby to even another set of mom and dads. To drive this further, let's look at an even easier example. I call this the theater recursion method. Let's say we're sitting in a row of the theater, and we don't know what row we are, and we don't want to count. Hey, what row am I in? So we can easily ask the person that's sitting in the row in front of us, because we know that we're in the row plus one of their row. So let's ask them, what row are you in? Well, they don't know either. So let's say they ask the person in the row in front of them, what row are you in? And that person in the row in front of them says they don't know. So we would continue this process until we eventually ask the person in row 1. Since there's no rows in front of row 1 would simply say, hey, I'm in row 1. And then row 2, well then I'm in row 2. And then I'm in row 3. And finally back to our row. Now we know, we're in row 4. So let's see how this actually works recursively. We initialize Mario. What row am I in? Well, Mario doesn't know, so he asks Koopa. Well, what row is Koopa in? Koopa doesn't know, so he asks Toad. What row am I in? Well, Toad doesn't know, so he asks Tanuki Mario. And since Tanuki Mario is the base case, Tanuki Mario is in row 1. So Toad is in row 1 plus 1. Toad's in row 2. And Koopa's in row 2 plus 1. So Koopa's in row 3. And that means Mario's in row 3 plus 1. Mario's in row 4. And the recursion is done. But remember, in order to understand recursion, one must first understand recursion.